In this video, let us see about how to convert a decimal number to hexadecimal number. The step-by-step procedure is given. You can also learn how to cross-check your answer. This topic will be very useful for competitive exam preparation. Decimal numbers are 0 to 9. Totally 10 numbers will be there and the base is 10. For hexadecimal number, totally 16 numbers will be there. So it includes all the 10 decimal number 0 to 9 plus 6 alphabets A, B, C, D, E and F. So totally 16 numbers will be there and the base is 16. Let us learn the conversion using 3 examples. So first, a decimal number of 9 is given. So what will be the equivalent hexadecimal number? You see this table, decimal and hexadecimal. So we know in decimal 0 to 9 and hexadecimal also has 0 to 9. So for 9, it is again in hexadecimal, it is 9. Only after 10 we have A, B, C, D, E, F. So whatever number is given in decimal less than 9, you can write the hexadecimal equivalent is equal to decimal number. Let us consider another example. The decimal number is 78. So to convert decimal to any number conversion, we have to divide by the base of that number. For hexadecimal, the base is 16. So let us divide this by 16. 78 by 16. So quotient we are getting 4 and the remainder is 14. So what is the equivalent of 14? We don't have 14 in hexadecimal. So what is the equivalent of 14 in hexadecimal? It is E. So E, instead of 14, you can write it as E. So the answer is 4E. Let us see how to check this answer is correct or not. Same procedure. So we got 78 is equal to 4E. For E, for this position, what is the weightage? 16 power 0. For this position, the weightage is 16 power 1. So 4 into 16 plus E into 1. So E value is again 14. So you will get 64 plus 14, that is equal to 78. So the answer is correct. Now let us take another example with the decimal point 450.32. So when you have a decimal point, always split the integer part separately and decimal part separately. So this integer part, first it should be converted into hexadecimal. Then in second step we have to convert this fractional part into hexadecimal. So let us take the integer part, that is 450 first. 450 divided by 16. So quotient is 28 and remainder is 2. Again divide by 16. So the remainder is 12 in this case. The 12 is equivalent to, in hexadecimal, it is equivalent to C. So now for 450, what we are getting is 1C2. Always start from bottom to top. Okay, you put the arrow from bottom to top in case of integer part. 1C2. Next we will do the fractional part. First let us check whether this conversion is correct or not. So for each position, mark the weightage. For this position, it is 16 power 0, it is 16 power 1 and here you have 16 power 2. So this is 256, this is 16 and this is 1. So let us multiply it. 1 into 256 plus C. What is C? 12. 12 into 16 plus 2 into 1. So if you add it, you will get 450. So the answer is correct. Next, let us take the fractional part. So here we have 0.32 multiply by 16. It comes around 5.12. Take the integer part separately. So you have 5 here. Now this 0.2 you multiply by 16. It comes to 1.92. Again take this integer part separately. Then again take the fractional part alone and multiply by 16. So repeat this process. So here you are getting 14. So for 14, what is the equivalent value? It's E. So you should write here E, not 14. Okay, you should write here E. So you are repeating the process. Here you are getting 11. For 11, the equivalent hexadecimal number is B. So write B. So here you are getting 8. So you can write 8. Now for integer part, we always take from bottom to top. This is fractional part. So you should start your arrow from top to bottom. So for 0.32, equivalent value is 51EB8 hexadecimal. So the decimal number 450, you have this value. For 0.32, you have this value. For totally, we can write it as 231.51 EB8 hexadecimal number. So if you see the number system, we have seen 4 number systems so far: decimal number, binary numbers, octal number and hexadecimal number. So you see in all 4 cases, decimal number we know 0 to 9, 10, 11, 12, it keeps on going. Now if you see the binary number, you have only 2 numbers, 0 and 1. 0 and 1. So after 1, it goes to 1011. Then again, number of digits will increase. It will go to 100. Okay. Now if you see the octal number, octal we have 0 to 7. So after 7, it will start from 10. There is no 8 in octal number system. Instead, after 7, it will start with 10, 11, 12, 13, 14, 15, 16 till 17. Again, it will go to 20. If you see hexadecimal, it will be like that. So, till 15, till 9, it is same. After that, you have alphabets. Again, for 16, it starts with 10, 11, 12, 13. Like that, it keeps on going. Therefore, to convert any given decimal number to any number, that is binary, octal or hexadecimal, you can apply the successive division method. Suppose you have a decimal number of 91, you want to convert it into binary, divide by 2. So divide by 2, when you divide 91 by 2, 45 is the quotient and 1 is the remainder. So write the remainder separately. So you keep on dividing till you get the final value. So after this you cannot divide it, you can stop it. Here remainder is 0. So always start from this value. So you put a arrow mark like this and write the value as 91 equal to 101111 to the base 2. It is always necessary to mark the base of the system. If you didn't mark the base of the system, then it will be considered as a decimal number. Again, if you want to convert this same number into octal, divide by 8. So similarly, you mark the remainders here. Now the answer is 133 to the base 8. Same number you divide by hexadecimal number, you will get 5 and a remainder of 11. 11 means it is B in hexadecimal. So the given number is 5B. So let us summarize what we have seen. Hexadecimal numbers are 0 to 9, then 8 to F alphabets are there. And the base of the number is 16. For conversion to hexadecimal, that is decimal to hexadecimal, divide the number by 16, note the remainder and write the remainder from bottom to top. If you like the video, do subscribe to Read Electric Vehicle channel. Thank you.